Good morning, afternoon, and evening, everyone, and welcome to another session of Postgres Pulse. This marks our 11th episode, and just a quick introduction for those who have not tuned in before. We're here basically discussing questions and solutions and problems and opportunities we see around Postgres. A couple quick guidelines for folks before we jump in. Please make sure to use the Q&A button to ask a question when you do have a question to pose to us. We'll go ahead and unmute you when you have the opportunity to talk, to walk through your question. The one last thing that we would note is to make sure that you're obviously civil and we're abiding by the Postgres Code of Conduct. So let's jump right into where we're touching on this week. The session this week is focused around synchronous commit and synchronous replication as a whole for streaming capabilities within Postgres. The blog that we had published last week was titled Synchronous Commit, Balancing Safety and Performance. And really what it touches on is one particular customer that we had seen several months ago was using synchronous streaming replication. They had a failure of their primary, they promoted their standby and went into production, went about fixing the issues that they had with the original master, the original primary, and discovered that they actually had storage corruption. Because of the fact they were running synchronous replication, they figured they were safe to effectively blow it away, replace the storage, and go about their day with the new standby as the new master. The problem that they ran into was that as the next day proceeded, they started to run into queries that would actually fail out. They were intermittent, it wasn't the majority, it was an inconsistent minority. They were able to identify that it appeared to be transactions that had actually been committed during the window in which the original primary had failed. At that point, they reached out to support. So EDB support engaged, and after digging into both the problem description they had and the configuration, we saw that they were doing a synchronous commit local. There's a whole lot of opportunities and nuances you can have associated to how you configure synchronous commit. And we'll get into that later, but ultimately it meant that the transactions that had occurred while the original master was failing and during the time that the new standby was being, or the old standby was being promoted to master, were effectively gone. So we worked with them to understand how big of an order of magnitude that loss was. Turned out it was about 15 meg or thereabout, or 64 meg rather, of data that was lost because of the fact that their data was all geolocation and currency was really the king of their transactions or their data needs. They decided that instead of doing a point-in-time recovery, losing 2 days worth of data, they would go with moving forward and understanding that they had a small window of data that was lost. Next step was really, is this the best choice of configuration going forward? Now, for them, we elected to go with synchronous commit to on, which allows for some level of granularity while providing some safety and some performance gains as well. But it really begs the question for everyone, what should I focus on when I'm looking at how I go about setting up my replication when I'm doing streaming? And there's a whole lot around that we can really kind of dig into as we talk through things. Bruce, I'd kind of like to get your perspective on one, the various ways that you've seen or that you consider to be the most successful for configuration, and two, what are some of the common pratfalls that you see when folks are going about and designing for this?
Yeah, it's, you know, I wish this was a sort of shining light of Postgres wisdom, you know, but I'm not sure it is. You know, this synchronous commit has evolved over time. Originally, there was just an on and an off setting, right? Which, you know, was still not completely clear because once we implement the on and off setting, people are like, well, what does on mean? Does it mean that the data is on the replica? Does it mean the data is on the replica and durably stored on the replica? Does it mean the data is on the replica and durably stored on the replica and replayed so it's visible to sessions running the replica? Like, which one is it, right? I'm not even getting into local yet. So we kind of looked at it and we're like, wow, okay, so now people want more granular control on that end. And what we ended up coming up with, and I'm not sure I'm super proud of it, is a whole bunch of options for synchronous commit. And I think this is where the person kind of got tripped up. They're like, okay, there's off. Well, what's the next one? Okay, local, I'll just use that, right? And not really reading, I'm afraid, the full paragraph to understand exactly, and even though it's in the documentation, I sort of, we poked around, and there's not a whole lot of, hey, this is a big problem, or hey, you should have watched this in the blogs or anything. I'm probably seeing I should write a blog about it. So it is a little tricky. You would think there's just one setting, but there's always a performance trade-off between how durable, how visible you want it on the replica, and how much performance penalty you want to take. And because Postgres give you that option, you now as an administrator have to decide, I want it on the replica, I want it on the replica durable, I want it on the replica replayed, and then local will talk about that as well.
Well, so it really helps, Bruce, to hear the history on this because you stumble upon this, and Jamie goes over this in his blog post. There's a ton of options, and they all have different but interlinked effects. And the first thing in your head, why? Just give me the on-off switch that does everything right. But
Well, I'm gonna even pick on that because the on setting, when you finally look at the docs, the on setting appears fairly arbitrary. I mean, right? It's very hard. You're asking for an on-off setting, and I'm saying not only are you going to give you an on-off setting, we're going to give you a whole bunch of other options, and we're going to arbitrarily pick one of these as being on,
yeah,
right? Which is kind of embarrassing, but I understand why historically it was done that way, and I understand in terms of user API, we kind of want to steer people, I think, toward the most logical option, which I think is on, right? At least historically and probably practically. But there are a whole bunch of other reasons you'd want the other options. And I'm afraid that the person who, if this particular customer fell into the pitfall of not understanding all the options, just picking the first one, which actually had no reference to replication at all in a way. So that's the real pitfall there.
so the actual evolution here is, I mean, there was an on that did everything possible at a
No,
point in
no,
time.
No.
no, no,
No.
because yeah, this is the problem. Because if you it's maybe the docs need improving, but it's like a spectrum of options, right?
Yeah.
And obviously off is off, right? And the at the other end is replay. So
Yeah.
not only are you getting it on the replica, not only are you durably storing it on the replica, but you're making sure that that wall has been replayed. Now, there's a whole bunch of reasons why wall might get delayed from replaying, including trying to avoid cancellation of existing queries. You may not have hot standby feedback turned on, and therefore you may get vacuum records that you don't want to apply right away. So if you are on setting or your default setting was this replay option, where a lot of people, I'm afraid, would say, I don't want replication, right? Because again, the only reason you would want replay is if you're replaying queries on the standby and you want to make sure that whatever you see on the primary is the same on the standby. And there's some settings like that, but certainly for disaster recovery, it's not necessary at all, right? As long as the wall records are there, you bring the replica up, it's gonna have all your data, right? Which is what this customer was worried about. So that's the point, that in fact, giving them the full, this is why the trade-off, if you trade off too far and you go to maximum features, the performance might be so bad that say, oh, Postgres stinks, I don't want to use replication, which is definitely not the direction we want people to go in.
Mhm.
Ah, okay. So you're effectively choosing the option that gives you some data
A
safety.
good trade-off, yeah.
Yeah, yeah. You're trying to hit a middle road there. And over time, people have asked for other guarantees, for more strict or less strict, depending on specific application needs, probably.
Yes,
And
yeah,
so
but
all these
different
other options have been
different
thrown in here.
setups. Yeah, if you're not running, you may be running data warehouse queries on the standby. You don't need replay, right? Why are you going to slow down the primary? This is the problem we've always had. I mean, Postgres, that streaming protocol is very lightweight, so people are that everyone, as soon as we got it, everyone rushed to streaming replication for high availability. But if you start layering it with a whole bunch of things that maybe people don't want or don't need, your performance is going to be so bad people are going to not use it at all. So that's really your that's your calculus of where do you put that line.
So
You,
Vibor, you've done a lot of work with this. Uh,
yeah.
And you had a phrase you mentioned the other day, kind of describing succinctly this set of trade-offs.
Mhm. Yeah, so whenever somebody deciding, I mean, when customer reach out to me especially, and they ask for the synchronous replication, I always talk to them about three important key points, mainly maximizing the availability, which is maximum availability, maximizing the performance, what do you want, to performance perspective, maximizing the protection, how you want to protect your data or make it available when you want to, right? So these are the key important points: maximum availability, maximum performance, and maximum protection. And based on these things, right, decide where you want to find out a minimum, or I would say stable ground, which will be good for your application. And that's why I think Bruce has really well pointed out. That's why synchronous commit, that's a parameter, has many options. Like it has the option called on, where PostgreSQL makes sure that whatever transaction you're committing, it's get returned to a disk on the primary server, flushed down, and at least one of the standby can just confirm that they have received the wall. Even the wall is not written on the disk itself. And there is other option called local, which is purely asynchronous mode, where master of the primary is going to confirm the transaction is committed if it is flushed to the disk, right? And there's a remote write. In remote write, standby also confirms that, hey, I received the wall file. I've also flushed the wall file on the disk. And that's my confirmation that his data is protected on the disk now. And the last option is called remote apply, which is making sure that whatever data is received by the standby is also applied, and so the transaction is visible to the user who are reading the data from the standby side. So you can see all these different varieties of the values available for synchronous commit parameter, and user can control what level of durability or the protection they want, right? So like in maximum availability case, what people want, they go with the synchronous commit equals to on, which means data is written safely on a disk and standby confirm, hey, I'll receive the data, right? But it's not really like was applied on the, or flushed on a disk. Some people go up to like remote write, right, which is again kind of a protection. But in availability case, you're focusing on the availability of the system, right? That is a key thing.
You're
And
trying to never delay a request more than you
yeah,
have to.
never delay the request. Yeah, and then there's a maximum protection, which is another side of the spectrum, right? Where maximum protection means you go with the remote apply, means whatever is getting written to the primary is also available on the standby side, and user can query directly on the standby. There is also one more important piece. Whenever you want to go with the maximum protection, you would like to have at least two standbys, so that two standbys can confirm to the primary that they have received the data, right? And in maximum performance, when you're looking purely performance, then people go with the asynchronous application, right? Where they know that streaming application is going on, but maximum performance they can achieve from the master side.
So
So these are,
when you're helping somebody work through, when you're jumping in to help somebody analyze this,
Mhm.
that's the first question you ask. Then is that these are your three dimensions. Which one has priority
Yeah,
in your application, in your setup, in your system? Are you demanding maximum availability, maximum performance, maximum reliability, uh, and then you work backwards from there.
correct. So yeah, it totally depend on the use cases, I would say. And like, for example, if you have a transactional system, right, where you cannot lose a single transaction. Transaction is important for you, and it's like a OLTP environment where you're just committing a small transactions, and that should be available on the all standbys for the read purpose, right? The remote reply makes sense. Again, there are other factors too. You would like to make sure that you have a good amount of bandwidth between the master and standby, because in case of remote apply, primary is going to confirm the transactions committed if it is already applied on the standby side. So, so all the other parameters, we look at it and we try to, make sure that they configure their PostgreSQL in such a way that they get a lot of good benefit out of it. And sometimes people want to balance out between the performance and the availability. In availability case also, you go with the remote write in some cases. And let's say if you want to go with the confirmed, remote apply case, then there are some more tweaking we do. We help customers. In PostgreSQL, there is a one parameter called wall sender timeout, right? Because you want to make sure that even suppose one standby is gone, right, due to network failure or something happened to the standby, but you still want to serve user request, right? So that's why you would like to tweak that parameter called wall sender timeout. Again, by default, 60 minutes, which is good enough. But we again try to tweak that parameter based on the bandwidth, based on the response, right? How good network environment you have, how much TPS you want to achieve.
So yeah,
So
this is real important to emphasize, I think,
yeah,
because you look at Jamie's situation, the one he blogged about there. Um, you have somebody there looking at this wall of options, and they're, near as we can tell, just picking one out of a hat, picking the first one. They're not sure which one actually best meets their requirements. Maybe
Right.
they haven't sat down and actually done a thorough analysis of what their application system needs.
yeah,
And what you're describing is you start at a very high level. You're nailing down what the total requirements are, what the primary requirement is for availability, performance, etc. And you're working down from that into, all right, now we're getting into fine tuning this. What
yes,
options can we tweak to wring the
yeah,
maximum amount of performance out, since that's our priority? What can we tweak to maximize performance within the constraint of availability, which is our top uh, priority? And if you haven't established that up front, how would you know?
correct. Yeah,
Right.
how would you
Right.
know?
Yeah,
Yeah,
and look at the fact that this is only while we're talking mostly at the server level, right? When you start to go past the server, before you had mentioned a piece that kind of brings us down another side branch, which was making sure that you've got at least two standbys, right? Which brings us to another command that allows you to modify how you go about doing this, right? Where you're looking at synchronous standby names. So once you've decided, okay, I'm going to be doing this type of synchronous commit, be it remote apply, be it remote write, be it on, whatever, then you've also got to go ahead and decide, okay, from a quorum perspective, how do I want this to behave? Do I want
yeah,
standby A to have the commit?
mhm,
Do I want standby A and B? In what order? There's a whole lot of layering that comes to this. And then this is all just assuming we're staying at the level of the server, right? You start digging into the finer grained ability that you can apply to tweak this, and you get into basically session level and transaction level. And Bruce, you had a blog recently about when does a commit happen that I think kind of tails into explaining this piece of it or the mechanics of this perhaps a little bit more. It certainly puts nuance on it, right? Could you talk a little bit about that?
Sure, it's the blog from June 3rd. I mean, I think the key thing Vibhor's saying, and maybe we didn't say it clearly enough, is once you decide we're gonna wait for standby to do something,
Yep.
whatever it is, remote apply,
mhm,
remote, right, whatever, you're now hostage to that machine, right? Now, again, as Vibhor said, if you're going to be hostage to another machine, you just dropped your availability by 50% because now either machine effectively could disable rights on that primary, right? So that's why you almost have to have two machines, and then you need to set up synchronous standby to figure out kind of what goes on, right? And then the third aspect we've talked about, which is what Jamie just talked about, is the idea of a mixed workload where I've got some transactions or some sessions where I want it to be durable. I want it to be on the replica. I want it to be either remote apply or remote. I can even mix them, right? And I can have other sessions where I don't care about it at all. And that's where the ability to change synchronous commit at the session level per user, per transaction comes in. So you can now say, okay, I want to wait for these things to happen on the replica. I don't care about these other things. And it basically creates a queue. So the wall is one long stream of changes that are effectively serialized as best that I can explain it, and therefore you're going to say, I'm going to do a whole bunch of wall writes and a whole bunch of commits potentially, where I'm not even going to wait for those to get to the replica at all. And then I have a whole bunch of other ones where I'm actually going to wait for an apply. I'm going to wait for a remote write. I'm going to wait for a remote durability, whatever. And you can basically pick which ones you want. And you're still in a serial stream of data. So as soon as one transaction has to be durable or has to go to the replica, everything before it, all wall activity before it also has to be synchronously sent or
And see, you can't really make a sane decision on whether that's appropriate at the database level, because the database is going to do it the same way regardless, right? Your stuff's going to has to happen in the order that it's committed. You can't jump in queue.
You can't jump in queue. All you can do is almost the way you have to think of it is, do I want my session to wait for that action to happen, right? And if you're doing a bulk load, might say, I'm going to run this batch job, and if it doesn't happen, I'm just going to blow it away and recreate it, right? Or something like that, right? That would be a perfect example where you have a replica and you're saying, at the end, I'm going to do a huge bunch of stuff. It might take a couple hours. And at the end, I'm just going to do one synchronous transaction, and then that's going to flush everything to the replica, right? Instead of doing thousands or perhaps millions of transactions, all of which are waiting for the replica to acknowledge. And you're like, I don't really care about any of these intermediate results. I just want all this stuff to happen. And then at the end, I'm just going to do a synchronous.
Right. Conceptually, you have two steps. You have the bulk load, and then you have whatever you do after the bulk load that has to know that the bulk load is completed.
But you can even go more than that. For example, we talked about earlier how expensive remote apply is, right? We're pretty horrified that would be the default, right? And it isn't the default, right? But I can imagine some cases where you might want to have on or remote write as your default for most transactions, but then you might want to do a couple things like update a lookup table, and those you may want to be remote apply. And what my blog entry basically explains is that effectively in that particular case, you do the update locally to the lookup table. You update the C log or the transaction log, exact log it's called now. You update that, and then you send this is from a June 3rd blog entry, you send the information to the replica and you wait to come back. And once it comes back, so you've already durably written it to the primary, but it's not visible to any other sessions because you haven't updated the proc entry yet. So you send the thing off, you wait for it to come back. Then as soon as you update the proc entry, now everyone sees the transaction status is being updated and everybody. But I can imagine if you're doing synchronous stuff, you're saying, I have a lot of applications looking at the lookup table. I want to make sure that lookup table is on the replica before anybody on the primary machine sees it. That would be a clear case where you're actually using a more extreme commit capability for specific transactions.
See, that's cool because you're not tied to one client, because you could do that any number of ways. But if you have multiple clients, if you have multiple independent bits of software all relying on this database, and you need to be sure that they're seeing data consistently. If you got that requirement at your application level that everybody sees the same data at the same time, you have that option.
Right.
Probably a terrible idea to turn on by default, but if you get in that situation where we've got some gnarly race conditions here, we really can't have that. You can make it happen.
Yeah. I mean, so as I think whatever example Bruce has mentioned here, right? In some situations, people do that, but in my opinion, people should actually evaluate when they want to do this kind of a mix and match thing into the one session, because you can think about a session in which you have set this synchronous commit equals to remote apply. That is going to take a lot of time, right? And of course, the performance will tank. Maybe you would like to look at the Postgres and other features which could be suitable for your specific need, like the lookup table, which you want to make it available for everywhere, right? Maybe in that case, for that specific lookup table, maybe you would like to use logical replication in synchronous mode. Again, another solution. But yeah, I mean, don't try to solve all the problems with the one specific solution which you have. Synchronous commit is made for some special purpose, but if you try to do more mix and match in that synchronous commit, right, that may impact to your application performance, and then you may start thinking Postgres in a wrong way. Postgres gives you many options, right? So choose as per your need, I would say.
No magic bullet,
Yeah,
but a lot of tools that if you know what you need, if you take the time and analyze, you
yeah,
can sit down and design the system to work in that way.
correct.
Well, cool. And
Great.
Jamie, this came up earlier. I was kind of tickled to realize this. I hadn't really ever thought about it, but this idea that you can have different options for commits across different connections or even per transaction. This came up earlier in the week, and Jamie dug up this blog post from oh, who did this? Chris Winslet
Yeah.
back in 2016, and he goes over all the different options here on compose.com. Kind of lays out the
Yeah. So
thought
Josh just
process
dropped
there.
that into the chat here for folks, and we'll make sure to include it when we post this later. It's interesting because it allows you to have a much greater degree of atomicity, right? You can now decide, okay, you know what, I don't want to handle this necessarily at the or use what I have as configured as default at the database level. I want to be looking at this per session, per transaction. Per transaction is, as noted in the article, becomes really interesting when you're doing things from a NoSQL perspective. But across the use cases, it's a matter of making sure that however you configure it, you know, step back and actually evaluate what are the performance implications of all of these customers or all of these recipients of how I configure this, right? And there's a couple posts out there as well around some performance testing where you may have remote apply versus remote write versus just on. And then there are obviously cascading implications when you look at how you configure synchronous standby names. But ultimately, there's no golden rule. There's no silver bullet that says, this is your answer. This is the formula you must use. This is the grand unified theory of performance, right? It's a matter of understanding what you need in your implementation.
If you're writing the exact same app, if you're constructing the same system that you did last week, then however you did it then probably works for this one too. But if you're doing something to address a specific need, you're probably doing something that's a little different, and you have to nail down the requirements, including the behavior of commits.
Absolutely. And the particular customer that we had kind of started this track off with ended up going with synchronous commit set to on, because as the point that was made earlier, it's kind of a balance, right? You allow it to get not just committed to the wall of the primary, but also the walls of the standbys where they're named in synchronous standby names. And you're not waiting for it to do a full replay, because that is obviously the most expensive iteration of what you can do there. So it gives you some durability while it doesn't sacrifice all your performance.
Yeah. So going back to Vibor's three things, right?
Yep.
Their primary concern was not losing data, and they had to configure it to allow for that without impacting performance, without
Right.
digging into their bandwidth or CPU time.
Exactly. So the answers are a myriad. You really have to take into consideration all the options you've got out there, make sure you test what you configure, and then bring that into production in a responsible way. There is no one answer for everyone. To Josh's point and to Bruce's mentioning at the onset, a simple on-off doesn't necessarily work for everyone, or even the majority of use cases we see. It's all a matter of evaluating what you have as your overall needs. So I want to thank everyone for the time this morning. I think this is a pretty good insight into just one small portion of Postgres replication, where we're looking at streaming and we're looking at streaming implications of synchronous commit.
May
There's
need
a
a
lot
few
more.
more of these.
Yeah, absolutely. There's a lot more detail, both in the content that we've posted into the chat, and we'll append to the YouTube as reference content, as well as the blog post that this session was led off with. So I would invite everyone to take a look at that. And if you have any questions, feel free to post them to us either on Twitter or on LinkedIn, or of course via postgresPulse@enterprisetv.com. And we'll see you again in 2 weeks, where we're talking about maintenance and the general practices we see, as well as the general pratfalls that we see. So thanks everyone for your time. Guys, thanks for another great session, and I hope everyone has a great day. Take care.
Jamie. So long.
Thank you.